As a hopefully brief indulgence, this aside is about how Blake's story showcases the most of the air combat fantasy that Crimson Skies has to offer. Not only is combat between airplanes showcased fairly often, but so too is an extensive sequence of battle using weaponized airships, of a kind and to an extent that has never been seen in real life. The portrayals combine not just the fantasy of a great airship as an airbase and home away from home, but also as a warship in its own right, fit to fight other such flying warships in a way reminiscent of the broadside battles of old wooden sailing ships. While the fantasy is easy to grasp and its appeal can be easily understood, the understanding of the real life technology of airships and their application can help bring a nuanced understanding of what the fantasy means for the world of Crimson Skies. In summary, the climatic battle of Paladin Blake's story involves the use of three airships facing off against a group of grounded pirate airships, plus one enemy airship far greater in power than any individual vessel in the sky. The common features regularly referenced are the airships carrying fixed-wing fighter aircraft, broadside fixed naval guns, turreted machine guns, tubed rocket artillery, and aerial torpedoes. At the surface level, these are simply listed features meant to make the combatants seem powerful, but also balanced in their stated differences. On a different level, they are part of a certain implication as to how airships can be used as an extension of military power. What's curiously lacking in any description of Crimson Skies airships is the specifications of the vessels and their complements in size and payloads. Supplementary materials for roleplay gaming may give numbers in terms of space occupied in hex squares, and some approximation of what that means, but what I'm getting at is that there's no unified understanding of how the parts of an airship take up space and have weight that has to come together into a finite vessel of a finite capacity represented by the airship's explicitly given size. Random numbers for engine power and lifting capacity may pop up here and there, but no one could realistically calculate how such technology would actually look or perform when put together into a vessel with all the parts needed to work as they do. For example, we get exactly one number for lifting capacity for an airship in story: 600,000 pounds of lift for payload from the airship Commerce. If this capacity for lift is represented by an ellipsoid of lifting gas with a circular cross-section and a length-to-width ratio of, say, 8, then factoring in the lifting capacity of hydrogen and helium, 71 pounds and 65 pounds respective per 1,000 cubic feet, and the volume of an ellipsoid, 4/3 pi multiplied by half the long axis and the circular radius squared, we get a radius of 65 feet or 130 foot diameter and a length of 1,010 feet, give or take a few feet as a difference between hydrogen and helium lifting capacity. The difference may not seem like much, and the dimensions may seem impressive on their own. But remember, this is in reference to lifting capacity, or alternately, its disposable lift, or its payload. The mass of air volume displaced by an airship has to support the mass of the lifting gas, the payload, and everything else an airship needs to be an airship in the first place. At the extreme small end, party balloons, or zero-pressure balloons, have very little mass aside from the lifting gas, so the difference between using hydrogen and helium is indeed very small. However, as an aerostatic device grows in size into a vehicle and a vessel, more and more structure is needed to support the lifting gas envelope, the crew, power plants, fuel, controls, and payloads that make an airship useful. Depending on how much of gross air displacement is taken by the non-payload structure, the difference in payload capacity between a hydrogen airship and a helium airship can be substantial. In general, for the same payload capacity and ratio of structure mass to displaced air mass, a helium airship has to be larger than a hydrogen airship. If you try to imagine airships as portrayed in the Crimson Skies, with steel frame structures, heavy weapons, armor plating, fighter aircraft, and helium lifting gas, any real-life reference of weight for such components would demand that Crimson Skies airships have to be not just exceptionally large, many times larger than they were conceived in real life, they'd have to be truly gargantuan in size, just to be usable in their written roles. Constructing vessels on such a scale would then be limited by an understanding of how such vessels would be pieced together, spar by spar, frame by frame, section by section, and so on. It may not be impossible if airship construction had the benefit of the shipbuilding capacity afforded to conventional water-bound vessels. Compared to ships of the 1930s, modern real-life military and cargo or cruise vessels regularly dwarf them, breaking 1,000 feet in length and displacing hundreds of thousands of tons at gross capacity. The harder part would be sourcing the sheer volume of helium needed to inflate fleets of these airships. In real life, when the US Navy constructed and experimented with the airships Akron and Macon in the 1930s, these two airships, plus a smaller Los Angeles ZR-3 airship, represented most of the helium-producing capacity in the United States at the time, not to mention what's needed to replace what leaks. The expense of helium in real life, plus its detriment to payload capacity, is a major reason airship concepts limited to using helium are rarely considered feasible enough for development into fully functional vessels fit for regular operation. Even documentation from the Navy in the 1930s stated that if war broke out in the Pacific and the airships Akron and Macon were to be used, they'd be filled with much more easily sourced hydrogen. Given knowledge of how often airship accidents involved fire, and that those included helium-inflated airships, using hydrogen in war wouldn't be the death trap as often portrayed in media featuring aerostatic airships. Fire mitigation would be of similar form and importance no matter what. So when Paladin starts the airship battle by giving orders to descend, increase speed, launch fighters, and bleed helium, it can be a statement either of the abundance of the gas that we've never had in real life, or that the expense of the loss is but the first stake in a high-stakes gamble that is the battle to come. With the fighters all loosed and engaged, Paladin's Zeppelins make their bombardment on the pirates and their Zeppelins, both the majority grounded and the one juggernaut waiting in the sky. Throughout Crimson Skies, Zeppelin-based combat is often based on shipboard naval artillery, but in an archaic twist, mounted broadside, and not in turrets, as expected of 20th century warships. Tube-launched rockets are treated in story as a new weapon innovation, and machine guns and turrets are the mainstay anti-air defense and bane of fighters. Notwithstanding the presence and proliferation of airship-mounted armor, why should airship-based combat be based on such artillery as large, fixed, broadside guns? When attacking and downing airships in real history, before there was a reliable way of setting fire to airships, downing them was exceptionally difficult. Simply poking holes in the envelope with bullets or artillery fragments just wouldn't cause the kind of leakage that would down an airship before it could set down in friendly territory and repair the damage. It wouldn't even slow down an attack by said airship. A more modern test where bullets were fired into the envelope of a Skyship 600, a relatively small airship, resulted in more than enough time for the vehicle to return to base before risking a crash. And the bigger an airship is, the longer it takes for damage to leak lifting gas in any appreciable amount. It would be far more damaging to hit the solid structure or gondolas and compromise the strength of the airship's structure. This also gets harder when the airship is larger, as the solid structure makes up less and less of a target profile compared to the rest of the fabric-covered hull. It would make sense then that leaking enemy gas bags or setting fire, depending on fire mitigation practices, would take a backseat to just outright blowing apart the fabric envelope, like popping a balloon when it wasn't overpressured to begin with. Using large bore artillery with explosive shells and foregoing the weight of a turret structure would push an airship as warship design toward multiple large fixed broadside guns, archaic in form but functional in their own way. As corollary, if downing an airship is dependent on explosive power to blow apart envelopes, it would make more sense to, paradoxically, forego armor and let shells pass easily through envelopes, to try and ensure that the passage wouldn't trigger the contact fuses of the explosive shells. Putting up solid armor guarantees that a hit sets off the explosive. If the armor doesn't hold up, blowing up a gas bag would be guaranteed. Indeed, it seems all the more implausible how often Crimson Sky's airships have the lift capacity to spare for armor, whether concentrated in certain parts like the bridge or expansively applied over the fabric hull. Another important function an airship needs to remain in controlled flight is the ability to control its buoyancy compared to its ballast. Unlike waterborne ships, where offloading cargo, people, or say a carrier launching airplanes simply changes how low in the water a ship settles, an airship won't hold its altitude based on its onboard load. Without adjustment of trim, it'll either rise or fall, with limits on both ends. Too light, and the airship will be forced to rise past the pressure height, where the expanding gas can rupture the envelope. Too heavy, and the airship won't be able to aerodynamically lift the vessel to stay in level flight. Additionally, without the ability to maintain a near-neutral static buoyancy, an airship has to use engine power or aerodynamics to control ascent, descent, or maintain altitude. If thrust vectoring isn't an option, an airship would be forced to use airspeed to essentially land like an airplane, a great big ungainly airplane, which would defeat the purpose of an airship's reason for being. This is relevant for Crimson Sky's airships because, as a matter of course, throughout air combat, they are constantly dropping fighters into the air, firing off bullets and ordnance, and all the while not one mention of recovering such ballast, excepting when airplanes are redocked mid-air, lighter on return. In real life, the Navy rigid airships Akron and Macon experimented with ballast recovery using machines to condense water from the exhaust of their engines to make up for the consumption of liquid fuel, since venting helium was not an option economically. German Zeppelin designs used gaseous fuel that matched the density of air, so consumption didn't change buoyancy or ballast. With neither method mentioned in Crimson Sky's stories, in-universe airships need to either have plentiful hydrogen to vent as a kind of anti-ballast to make up for what goes overboard, or to store lifting gas in a compressed state and displace less air. And both methods of which have to be more economically feasible than venting helium. Even in real life, the engineering for that kind of airship technology has not yet materialized nor spread, so the fiction of Crimson Skies leaves the feasibility ambiguous and secondary to the aesthetics. As the battle unfolds with blows of artillery between airships and dogfights between airplanes, it is but one piece of a larger military operation that turns it into a significant change in local geopolitics. Paladin Blake's battle with the pirates of the island city turns on his side's ability to gain air superiority, such that waterborne troop transports can bring masses of soldiers onto the island to secure it in the name of law, order, and justice. This is of such importance that when the battle seems lost, Blake's first instinct is to warn his vulnerable compatriots to flee before they can be destroyed. Not just the smaller airship, but also the troop transports and their warship escorts are considered vulnerable when the juggernaut airship commerce seems set to dominate the skies over the island. This implies that the firepower of airships with naval artillery is a great danger to vessels and troops confined to the surface. And this isn't the age of precision guided weapons. Effective military firepower is based on massed heavy weapons attacking a target all at once. An airship carrying the equivalent of an army battery aloft can take advantage of the ultimate high ground to increase the range to sight and fix enemies for better accuracy even before such ground-bound enemies can even see the airborne menace. Depending on either an airship's or watership's ability to see the incoming shells and evasively maneuver, one side will either have to forego accuracy to duck and dodge, or risk getting hit if they don't retreat. In story, we saw the Commerce fight and cripple Paladin's Aegis by quickly firing one broadside, then pirouetting in place to fire the second before Aegis could reload, aim, and fire again. Against this kind of power and agility, anything on the water wouldn't fare better. In this context, military victory would truly depend on air superiority provided by airships and the weapons and fighter aircraft they carry. A study of real history and the effectiveness of carrier-based fighter aircraft against ships and land units would confirm this too. Unlike the depiction of airships in the Crimson Skies as the airborne homes and stages in which unfold the adventures of the characters we have seen and will see, in Paladin's story we see airships as tools of military adventure and geopolitics that may fit this alternate world, and may inform any fiction involving familiar forms of geopolitics as well. From my perspective, airships are not commonly depicted as a central feature of militarism and adventurism, as opposed to set dressing that occupies the background. For alternate history, or steam or diesel punk adventurers, greater favor is given to other settings like great cities, buildings, and monuments, sprawling battlefields, and the people and constructs upon them, or even vessels great and small on tempest-tossed waters, or anywhere there's class conflict, or human constructs conflict with natural or supernatural forces. In Crimson Skies, as fanciful as the technologies and societies may be, they're not supernatural, and not necessarily beyond achievement. And the world of Crimson Skies is not fanciful. In many ways, it is very recognizably our world, if only portrayed in a stylized way at the surface level. However, with a base of knowledge in engineering, the possibilities in airship technology can fill out the world in ways that aren't written. Just like an understanding of socioeconomics and geopolitics can fill out what isn't written in the stories of the people in the world. The power of airships in Crimson Skies is to empower characters that would normally be dwarfed by state and national institution to go forth and have adventure, even adventure that's consequential to a larger world, albeit one built on the ruins of one great nation divided. Alas, where people and their empowerment are concerned, such as provided by airships and airplanes, state borders and geopolitical disputes don't really matter when they can fly.